Hey, and welcome everybody. Thanks for joining us today. Today's class, ask the question, is geothermal heating and cooling the right choice for me? My name is Dan, and my associates and I are going to help answer this question today. Today's schedule is going to be as follows. I'm going to be speaking first. I'll be going over geothermal theory and the components of a geothermal system and what all you have to make one work. I'll work for sensible energy, and my presentation will be approximately 15 minutes long. Next speaker will be Joel Popper. He'll be going over the different types of ground loops, as well as the increasing market share of geothermal systems. These systems, geothermal systems, are taking this industry by storm, that's for sure. Market share is going way up. Joel works for Alpine Geothermal, and his presentation should be approximately 10 to 15 minutes. The next speaker will be Justin Larson. Justin Larson works for Water Furnace, which is the maker of geothermal heat pumps, and he's going to be going over the Water Furnace savings calculator and the efficiencies of geothermal heat pump systems. He's also going to be going over the Water Furnace product itself. He'll be going over the different types of units and options that you can get on those units. His presentation should be somewhere between about 10 and 15 minutes as well. And then that will be followed with questions and answering section. So if you have any questions, write in, and we'll try to get to those questions. All right, let's get into it. My name is Dan Schmid. I'm owner and operator of Sensible Energy. Some of my experience and certifications go as follows. I have 15 years with hands-on HVAC experience. I have worked for a couple of large companies around in Denver, and that's where I got most of my experience through this stuff. I am NATE certified, and NATE certification basically sets rules and guidelines for heating and cooling professionals on how they should do their job and whether or not they know how to do their job. Another way of comparing it would be kind of ASE certifications for automotive technicians. They have that for heating and cooling, but it's called NATE, N-A-T-E. The next thing is ISPA certification. That's the International Ground Source Heat Pump Association. They also lay guidelines and rules on how geothermal heat pumps are supposed to be installed. And you guys want to make sure anytime you're having somebody install one of these systems for you, that they are ISPA certified. The next certification that we have is NAVCEP certification. That's mostly for solar thermal work. It's a set of test rules and guidelines, and it's a lot like the NATE certification, but for solar work. I have master mechanical certificates. There's the numbers. I have certificates in heating and ventilation. I have certificates in refrigeration, as well as steam and hot water. Those certificates are through Denver, and those are supervisory certificates. I've taken some business education classes as well as some trade classes at Red Rocks Community College, and my firm is a full design build contractor. Why should we go geo? First reason is because they're extremely comfortable. Geothermal heat pumps offer superior levels of comfort when used with radiant floors, forced air ductwork with 2 stages, zoning systems, and warm and chilled water air handlers. I should be able to keep a lower temperature in the house, still feel more comfortable than you would with a standard furnace. Geothermal systems are very reliable. Heat pumps have been used ever since air conditioning was invented. Basically, is just an air conditioner that reverses. Geothermal manufacturers offer some of the best warranties and support. Water Furnace gives tons of classes year-round on how to service your equipment, as well as if you have any problems, it's no problem getting a hold of somebody to ask them a question. Most of the heat pump systems should last 20 to 25 years with regular maintenance, and the ground loop will last twice that. It'll actually last longer than that, but the ground loop pipe does come with a 55-year warranty, so you can almost guarantee at least that one. They should get 3 heat pumps for the life of the ground loop. Another reason why we want to go geothermal is because it's extremely efficient. Geothermal heat pumps are up to 500% efficient versus natural gas equipment. Natural gas equipment has a max efficiency rating of 96%. And really, the most efficient they can ever get is 100%. So you can see they will never touch the efficiency levels of geothermal heat pumps. They are so efficient that they can actually pay you to operate it. If you work these things into mortgages or home equity lines of credit, you'll find that your monthly payment associated with the geothermal is less than the savings that you're accruing, so you become positive cash flow. Also offers competitive return on your investment, and it belongs in every investor's portfolio. If you guys are investors, you watch your money, you have portfolio stocks and those types of things, this geothermal heat pump systems work perfectly in portfolios due to how much savings that they actually offer. Geothermal is the right choice. You can do a lot of things with geothermal. You can integrate solar thermal with it. It's definitely part of a net zero home. You have to get the heating and cooling costs down low enough to where you can offset that. It uses HFC refrigerant, which is R410. There's no more chlorine in the refrigerant. R22 is the last of the HCFC refrigerants. Energy consumption is low enough so it can be made with PV solar or wind generators instead of mining natural gas. It gives us options for net zero homes. We can do lots of things with geothermal energy. This particular slide focuses on that. Looks at different things that we can do in your home. We can heat and we can cool your home. A lot of people think geothermal heating, all you can do is heat with it. That's not true. We can reject heat to the ground, which would technically be air conditioning. It works just as good as air conditioning. In reality, it is air conditioning. Next thing, in pools, you can heat your pool, you can heat your hot tub. You can take, whereas you used to have to do it with natural gas all the time or boilers, you can now do it with geothermal. We can treat pool rooms. We can treat the environment itself. We can heat or cool the pool room. We can dehumidify the pool room. Pretty much get whatever temperature we need, whatever humidity levels we need in that pool and make it comfortable. We can make domestic hot water with geothermal energy. There's an option to geothermal heat pumps called a de-superheater, which basically preheats your domestic hot water. And the way it does it is, anytime you're cooling or heating especially in cooling, there's a byproduct of that process, which is extra heat, extra energy. So we want to do something with that. So what we do is we take that energy anytime we're heating or cooling and we put it in a preheat tank for your standard water heater. It makes heating your domestic water very, very cheap. Also, if you have a water-to-water geothermal heat pump, we can heat your domestic water 100%. We'll have a zone for your domestic water, and we'll make all the domestic water with geothermal energy. Last thing we can do some specialty uses. These are just a couple things that we've seen in the past. You can chill wine rooms, you can chill coolers, you can heat up yoga rooms, hot yoga rooms, heat them up quite a bit hotter than not necessarily standard conventional equipment, but it can definitely take that extra load and make those rooms the way that those guys are looking for. The components of geothermal are as follows. I've got 5 components on this particular one, broken down. First component is the heat pump, kind of the heart of the system. You have ground loop, horizontal, vertical, pond loop, ground loops. There's quite a few different types of ground loops that we can do. Joel's going to later, so I won't get into it too much. Next thing will be your distribution system. What I mean by that is the way that the heat pump moves heat or cooling throughout the house. You can do a rain floors, forced air, we'll go over those a little bit more in depth here in a minute. Domestic water heater and de-superheater. The de-superheater is an option, so once again, we can make your domestic hot water with basically any geothermal heat pump that's out there. And then last but not least, we have system controls. You definitely want to have controls on these systems. It's important that All these systems get integrated correctly, or else they won't work well, they won't work efficient, and you got to have basic controls that can do that, such as thermostats that are linked together, um, outdoor setback controls that can lower the water temperature, those types of things. The system control is definitely an important portion of it. And here's the two pictures in the next couple of slides. There's just some installs that we did. This is a heat pump. This is a water furnace and vision heat pump with a 5-ton unit. That was installed at the Walsh residence, which is up in the Canyon City area. Here's another picture. Same heat pump, just a little bit higher. You can see on the left-hand side, all the way to the left of the picture, is the flow center. Those are the pumps that pump the water to the ground. To the right of that is the preheat and superheater tank. Next portion is the ground loop. The one on the right. And then the larger picture is the header trench that connects all the vertical loops together. Once again, Joel's going to go over ground loops, different types of ground loops, so I won't touch too much into that. But this is a picture of a particular job that we had done last summer. Here's a couple pictures of the distribution systems. This first one here is radiant floors. Picture on the left is using joist track, which is heat emission plates. With geothermal energy, you want to use heat aluminum emission plates. It's very important. Water temps down as low as possible. The lower the water temps, the more efficient the equipment is. You can take it to 125 degrees. Pictures to the bottom of that and to the right of that, that's radiant tubing. Basically, lay that tubing down, and then the basement floor guys come in and they pour concrete over it. So all those plastic tubing, all those pipes will be buried in concrete once the house is fully done. Here's another type of distribution system. This is forced air. This is sheet metal work. Picture on the left is different types of ducts. You'll see this typically through most homes. Picture on the top right is a round radius sheet metal tin. And then a picture on the bottom just showing you the unit, every return duct, and a supply duct. Here's a little bit on domestic hot water and desuperheaters. What is a desuperheater? Using what is called a desuperheater, ground source heat pumps turn waste heat to the task of heating hot water. During the summer, when the system is in cooling mode, your hot water is produced freely as a byproduct of the thermal process. In winter, with the heating mode, the desuperheater heats a portion of your hot water. Desuperheaters are standard on some units, optional on others. Standalone systems that will heat water all year round can also be purchased. With water furnace, the desuperheater is an option. It does not come standard. Picture on the right shows a little bit about the desuperheater. Shows two tanks. Tank on the right would be your primary water heater. Tank on the left would be your preheat tank for the desuperheater. Then anytime your heat pump is on, then you will get there's a pump here, and this pump will actually flow water out through these lines back into this tank. So that's the desuperheater circuit there. Next is going to be control. This is a particular control that I like a lot. It's an Ecobee. It's produced by Ecobee. It's a wireless internet-enabled smart thermostat. That's affordable, if you can believe it or not. The internet-enabled wireless Ecobee smart thermostat allows you to manage your home comfort from anywhere at any time. Unique features automate energy conservation to help you conserve energy, save money, and reduce your environmental impact. Most control systems offering Wi-Fi access cost well into thousands. I've seen them up to $20,000. While this great product can be installed for less than $700. It's a great low-cost way of controlling forced air systems. And you can't control hydronics with this particular unit, but your home or your vacation home from anywhere. If you have a smartphone, an iPhone, or a Droid phone, something like that, there's apps that allow you to connect to the Ecobee thermostat from hundreds of miles away. It doesn't matter where you're at. So you can turn up the thermostat, you can turn down the thermostat, you can check just to make sure that your house is up to temperature. So anyways, this is a pretty cool thermostat, and it's very, very affordable. Now here's some controls for hydronic hot water or hydronic controls in much more depth and force because we are in control of a lot more functions. We have to control operating temperatures, pumps, zone valves, and different stages of heat. These controls can also be linked to the internet with the right system. Luminar, for example, offers the CCN system, which can integrate many systems together and is accessible on the internet. And this particular system works great with solar too. We're trying to integrate solar and geothermal and outdoor setbacks and staging and all those types of things. It's very difficult and the controls are in depth. The CCN offers a product that basically is internet capable. Actually, with the controls, with the CCN unit, most of the time I can go on the internet and pull up your house and I can tell you what's wrong with the system from anywhere. That's what's really cool about it. It makes diagnosing systems very easy. Most of the time we come out with the parts we need before we know what we need before we even get there. I had a little YouTube video here that kind of explained how geothermal works. If you guys want to write that link down, you can check it out and it'll show you. Fortunately, I don't have it. I don't have it loaded up on the computer. So, anyways. Here's some geothermal facts. Heat pumps move heat from one place to another. From outside to inside a home, for example. That's why they're called heat pumps. All heat pumps do is move energy. That's it. It takes it from one place and it puts it in the next place. So if we want to air condition your house, we'll take heat out of your home and we'll put it into the ground. If we want to heat your home, we'll take heat out of the ground and put it into your home. I may have said that backwards. With AC, taking heat out, put it into the ground. Take heat from the ground, put it inside the house. Geothermal heat pumps are similar to ordinary heat pumps, but instead of using heat found in outside air, which would be an air-to-air heat pump, we rely on the stable, even heat of the earth to provide heating and temperature of the ground. Air-to-air heat pumps are also very efficient, but unfortunately when it starts to get cold outside, their efficiency drops off. And most of the time we need to heat the house when it's cold, so sometimes it doesn't work out. Studies show that approximately 70% of the energy used in geothermal heat pump systems is renewable energy from the ground. The Earth's constant temperature is what makes geothermal heat pumps one of the most efficient, comfortable, and quiet heating and cooling technologies available today. The energy that's taken from the ground technically is solar energy. It's produced by the sun. When we take it out of the ground, it's replaced by the sun. This isn't heat. This isn't technically geothermal heat like geysers coming out of the ground. We're just taking the heat out of the ground that the sun puts there. Surveys taken by utilities have found that homeowners using geothermal heat pumps rate them highly when compared to conventional systems. Figures indicate that more than 95% of all geothermal heat pump owners would recommend a similar system to their friends and family. And we're actually seeing about that same percentage of recommendations with our clients as well. Geothermal heat pumps are durable and require little maintenance. They have fewer mechanical components than other systems, and most of those components are underground, sheltered from the weather. The underground piping used in the system is often guaranteed to last 25 to 50 years and is virtually worry-free. The components inside the house are small and easily accessible for maintenance. Warm and cool air is distributed through ductwork, just as in a regular forced air system. There's nothing special about these systems, guys. They've been used for a very long time. A lot of firms have been around for something like 20 years. A lot of people are worried about how reliable they are, and they are extremely, extremely reliable. They are as reliable, if not more reliable, than the air conditioner that you have in your home. All these facts are taken from www.consumerenergycenter.org. If you want to check them out, look them up. There's the reference for you. A couple of things I wanted to talk to you guys about before I let you go. What matters when choosing your contractor? Well, we are not all made equal. You guys will find a very wide range of knowledge, quality workmanship, those types of things. Here's a few things that you guys can follow or you can ask for, look for when you're trying to make up your mind. Ask the heating and cooling or ask your contractor for their state licensing numbers and certifications. It's okay to ask for that stuff. They should have it. If they're on the up and up, they'll be glad to give it to you. Ask for references and proof of past experience. Make sure they're for real. Ask to see their insurance. You don't want a guy who this is his first geothermal installation. So make sure that he's done these in the past. Check up on them. Do your homework. They're expensive systems, so you want to make sure that what you're getting is what you're expecting. Make sure that your contractor is ICSPA certified. You guys got to make sure they're ICSPA certified. If they're not, it's very possible that they're just flying by night, don't know what they're doing. You don't know exactly what they're going to get. ICSPA is a great association. They've taken time to put together a test that makes sure that the guys know what they're doing before they even step into your home. Then NATE certified is a nice one. It's not as important as ICSPA, but it is fairly important. Basically, once again, like ASU certification for auto mechanics. NATE requires that you take tests and that you pass at a certain grade. And they kind of let the consumer know that contractor has done the extra work that it takes to prove to people that he knows what he's talking about. Last thing is look for a design and build contractor. You want them to take responsibility for the whole job. I've seen a lot of jobs where one job is broken up amongst 4 contractors, and then there's a problem, and nobody can decide who created the problem. So design build contractor. I in particular, Sensible Energy, we design and build all of our stuff. We take responsibility for it. We also do everything in-house. The only thing we don't do in-house is the drilling. We use Joel, Alpine Geothermal, for the drilling. Beware of the low bidder. He's most certainly leaving something out. I've learned that lesson the hard way. These systems aren't cheap, and typically, if you go for the low bidder, he'll up the price on you later, or he'll say he forgot something, something or other. But don't take the low bidder. You don't have to take the high bidder either, but just stay away from the low guy. If you go with the low guy, you may regret it. You probably will regret it. But anyways, up on that one. Also, if you guys, a lot of times people come to me and they want to get estimates. They wonder why my estimate is so much different than somebody else's estimate. And one of the reasons is because they're designed differently. One guy's design is different than the next guy's design. Probably doesn't have all the same options, all the same features. But if you truly want to know who's coming to you with the better price, then you need to have one design and then have all the clients bid off of that one particular design. That way they can't change anything. Everybody's bidding off the same pipe and schematics, same ductwork throughout the house, those types of things. So once again, if you want to compare estimates apples to apples, make sure they're bidding off of the same design. Well, that's about it for me, guys. You can contact me. Contact us at Sensible Heating and Cooling, otherwise known as Sensible Energy. We can be reached at www.sensibleheat.net. I can be reached personally at dan@sensibleheat.net. You can also reach us at telephone number 720-876-7166. That's the end of my presentation now. Let me introduce you to Joel with Alpine Geothermal. Joel's the leader in the geothermal. He's great at what he does. He's fast, he's efficient, and he's very knowledgeable. So let me pass you off to him, and other Otherwise, I appreciate it, guys, and I hope you have a great day.